Hello, I'm Bilawal an IBTP instructor, and in this brief video, I will be talking about a topic in IBTP maths known as normal distribution. In this video, we will be learning what is a normal distribution, what are the properties of a normal distribution curve, and how can we use normal distribution to find out probabilities that we are interested in. So let's start. So the very first question which should arise is, why is normal distribution so important? What's the reason of it? It is due to the fact that the characteristics of the normal curve and its shape is very suitable for models in which very large values or very small values which are extreme, are very rare, but majority of the values are in the middle range, and this type of scenario is very common in our daily lives. So normal distribution, to model our daily life problems, normal distribution makes a very good model. The normal variable which we can use in daily lives can be height, weight, age. We can use normal variables in finding out problems related to mass and volume. If, for example, you want to find or estimate time taken to complete an activity, and it can also be used in finding scores in text exam. The Cambridge system uses normal distribution to award grades to students according to their achievements. And lastly, as a normal variable is random in nature, so it can also be used to model it. If you can see over here, we see a very complicated equation known with f of x. This equation is known as probability density function of the normal distribution. But you don't need to worry, because we are not going to solve it or go in much detail in this equation. Rather, we are only interested in two parameters known as mu and sigma, which can be used to model the normal distribution. So for example, we have a random variable x. It can be modeled by the probability density of a normal variable that follows a normal distribution with mean u mu and variance sigma square. So basically, if a random variable follows a normal distribution, so basically this is how we write it. Random variable x follows normal distribution, and the parameter for a normal distribution is mu, which is known as mean, and sigma square, which is known as variance. As you all know from your previous knowledge, sigma is also known as standard deviation, and standard deviation is how much spread is the data along the ranges. If we look in the properties of a normal curve, we see that normal curve is always made up like a bell shape. It is symmetrical around its mu position, which is the mean position, and when we say it's symmetrical, it is evenly divided on the left hand side and on the right hand side of its mean position. You will always find the maximum point or the maximum value at mu, which is this one, and then you will also find two inflection points at sigma at mu plus minus 1 standard deviation. So these are some properties, and let's see how can we use them. So as discussed before, a random variable x can be modeled by a normal distribution with mu and sigma square. Now if you look closely in this curve, the first graph shows a random variable x which follows a normal distribution with mean 5 and standard deviation of 2. So this shows the green curve because it is symmetrical around 5. The next one is H2, which follows a normal distribution with mean 10, and again a standard deviation of 2, which you can easily see by a red curve. And let's go for the third one, which is H3, which follows the normal distribution with mean 15 and standard deviation 2. So here you can see this blue curve is symmetrical around 50. Now if you see that the mean of the first curve is less than the mean of the second curve, which is less than the mean of the third curve. So if you look closely, you see that the shape is same, but they are displaced, translated left and right due to the change in position of the mean. So this is one observation. Second observation is that if, as you can see, H1, H2, H3 all have the same mean, but they have different standard deviation. And as we know, standard deviation is spread of the data. So as the spread of the H1 is less, it's only 1, so you can see H1 is a thin curve. H2 is 2, so it's a bit more thicker than H1. And lastly, H3, which has the most standard deviation, is the most spread. But their mean position is 5, and data is more spread as standard deviation increases. So more the standard deviation, more will be the spread data. There is also an important relationship which you should remember, is that sigma square, which is known as variance, is basically the square root of standard deviation. So basically what you can say is standard deviation square is equal to variance. So sigma square is equal to variance, and this is a very important relationship to remember. So in the beginning we discussed that the probability, we can use normal distribution to find probabilities. So as you know that the probability of an event cannot be greater than 1, its maximum equal to 1. So we define the area under the normal curve to be 1. So as we discussed before, that it's symmetrical about mu, so it means 50% of the data is on the left side and 50% of the data is on the right side, meaning that 0.5 probability is on the left side and 0.5 is on the right side. When you add them, it's made equal to 1. So this is also another property for the area of a normal distribution curve, which we are going to use. Another very interesting fact about the normal distribution curve is that if you model a random variable with a normal distribution, you will find out that 68.2% of the data, 68.2% of the data always lies between mean plus minus 1 standard deviation. So always the 68.2% of the data will always remain between mu plus minus 1 standard deviation. If you increase your spread, so you will see that 95.4% of the data, of the total data, lies between mu and plus minus 2 standard deviation, and 99.7% of the data lies between mu and plus minus 3 standard deviation. So we can conclude that almost all our data lies between mu plus minus 3 standard deviation. That's why in the beginning when we were discussing why it is so important, we discussed that most of the values, or 99% of the values, lie in between the common ranges, which is a common daily life problem that we handle. So that's why normal distribution is a very important distribution to model our daily lives. Now the question arises, how are we going to calculate probabilities using normal distribution? As we discussed, or from our previous knowledge, we should know that the normal distribution has a bell-shaped curve, and area under the curve can be found out by using integration. Integration of function f of x, which we saw in the beginning, was a very complex equation. So if logically we integrate that function and put in the limits, we will be able to find probabilities from the ranges we are interested. But as it is a very difficult process and a complicated function to differentiate, integrate, hence we will not use that method. Instead, we will use an alternative method, which is known as cumulative normal distribution function. So if instead of integrating, what we will do is we will use this technique. For example, if you are interested to find probability between the points B and A, B being the upper limit and A being the lower limit, you can represent the probability distribution, cumulative probability distribution function in this form, where h, the normal random variable, is less than equal to B and greater than equal to A, can be represented by fb function of B minus function of A. Let's see how it works. As you know that IB is a technology based education system, so we will use GTC, we will not calculate it manually. So let's start a question. The question says, given that the random variable h follows a normal distribution with mean 3 and standard deviation of 2, calculate the probability that if the random variable h lies between ranges 3 and 1. So let's learn how to solve it by a help of a GTC calculator. So this is your GTC calculator. You go on to probability over here, and over here you go on to distributions. And now for normal distribution, we are always going to use normal CDF or inverse normal CDF. In this case, we will be going to using normal CDF. So our upper bound was to find the distribution between 1 and 3. So the upper bound would be 3, the lower bound would be 1. And our mu for this question was 3. Let us cross check. Yes, it's 3. And our standard deviation was 2. Now this will give us the area under the curve, which is corresponding to the probability we are interested in. So let's see. So the answer is 0.341. So the probability under the curve is 0.341. Here, see, we got the answer. Let's do another one. Before solving this question, it is important to understand how does this probability density function or normal cumulative density function works. Now, as discussed before, if this is a normal curve, the area under the curve is always 1. And this point is mu, as it is always symmetrical towards mu. Now when you try to find the probability of a normal variable, let's say h is less is equal to 3. Now as you see that 3 is a positive number. So on the right hand